friends. I am Satish Lele. I am a chemical engineer. I am working in the field of piping for last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about principle of pipe installation. The energy sources used are limited in magnitude and those will be exhausted by the end of the 21st century even if the present rate of demand is continued. These energy resources can be used for longer time if proper conservation methods are used and available resources are properly managed. In general, energy can be conserved by avoiding the waste. Therefore, to reduce the wastage of energy in form of heat, furnaces, and pipes carrying fluids at elevated temperature and turbines are insulated. What is thermal insulation? Insulation is defined as a material or combination of materials which retard the flow of heat. The materials can be adapted to any size, shape or surface. A variety of finishes are used to protect the insulation from mechanical and environmental damage and to enhance appearance. Where is thermal insulation installed? Thermal insulations are materials that insulate the components of industrial processes, not industrial facilities, such as power plants, refineries, and paper mills. Thermal insulations are installed to control heat gain or heat loss on process piping and equipment, steam and condensate distribution systems, boilers, smokestacks, bag houses and precipitators, and storage tanks. Function of insulation. Insulation is used to perform one or more of the following functions: reduce heat loss or heat gain to achieve energy conservation, protect the environment through reduction of CO2, NOx and greenhouse gases, control surface temperatures for personnel and equipment protection, control the temperature of industrial processes, prevent or reduce condensation on surfaces, increase operating efficiency of heating/ventilation/cooling, plumbing, steam, process and power systems, prevent or reduce damage to equipment from exposure to fire or corrosive atmospheres. Assist systems in meeting criteria in food and pharmaceutical plants. Reduce noise from mechanical systems. Condensation control. Specifying sufficient insulation thickness with an effective vapor retarder system is the most effective means of providing assistance for controlling condensation on the membrane surface and within the insulation system on cold piping, ducts, chillers and roof drains. Sufficient insulation thickness is needed to keep the surface temperature of the membrane above the highest possible design dew point temperature of the ambient air so condensation does not form on the surface. The effective vapor retarder system is needed to restrict moisture migration into the system through the basin, joints, seams, penetrations, hangers, and supports. By controlling condensation, the system designer may control the potential for the rating system service life and performance. Corrosion of pipes, valves and fittings caused by water collected and contained within insulation system. Process control. By reducing heat loss or gain, insulation can help maintain process temperature to a predetermined value or within predetermined range. The insulation thickness must be sufficient to limit the heat transfer in a dynamic system or limit the temperature change with time in a static system. The need to provide time for owners to take remedial action in emergency situations in the event of loss of electrical power or heat sources is a major reason for defection in static systems. Personnel protection. Thermal insulation is one of the most effective means of protecting workers from second and third degree burns resulting from skin contact for more than 5 seconds with surfaces of hot piping and equipment operating at temperatures above 55 degrees centigrade. Insulation reduces the surface temperature of piping or equipment to a safer level, resulting in increased worker safety and the avoidance of worker downtime due to injury. Sound attenuation. Insulation materials can be used in the design of an assembly having a high sound transmission loss to be installed between the source and the surrounding area. Sometimes, insulations with high sound absorption characteristics may be used on the source side of an enclosure to help lower the exposure to people to noise in areas immediately around the noise source by absorption and thereby contribute to the reduction of the noise level on the other side of the enclosure. Aesthetics. Most insulation systems in commercial construction are not generally visible. The common exceptions to this are found in equipment rooms where the heating equipment, cooling equipment, and the associated piping are visible to the personnel who work or otherwise must access these areas. It is common practice to require a finish and neat appearance for insulation surfaces that are visible within the building envelope. These surfaces may also be painted or covered for a more acceptable appearance in the case of hospitals, schools, supermarkets, restaurants, and even in industrial facilities for food processing and computer component manufacturing where visible to the occupants. Understanding heat flow called heat transfer. In order to understand how insulation works, it is important to understand the concept of heat flow or heat transfer. In general, heat always flows from warmer to cooler surfaces. This flow does not stop until the temperature in the two surfaces is equal. Heat is transferred by three different means: conduction, convection, and radiation. Insulation reduces the transfer of heat. How insulation works. The basic requirement for thermal insulation is to provide a significant resistance path to the flow of heat through the insulation material. To accomplish this, the insulation material must reduce the rate of heat transfer by conduction, convection, radiation, or any combination of these mechanisms. This provides information on three general types of insulation: mass insulation with air or another gas with thermal properties similar to air within the interstices inside the material, many cellular insulations, and all fibrous and granular insulations are of this type. Mass insulation with low conductivity gas within the interstices inside the material. Some closed cellular insulations are of this type. Reflective insulation bounding along the both sides of an air space. Many insulation facings such as asbestos or foil, scrim, craft are of this type. Physical properties. Mass insulation. For mass insulation types, the most important physical property is thermal conductivity. Material with lower thermal conductivity allow less heat to be transferred per unit time, per unit temperature difference per inch in thickness, all other items being the same. Material with lower thermal conductivity are better insulators. Commercially available mass insulations have low thermal conductivities. Reflective insulation. For reflective insulation types, the important physical property is low surface emittance. Surfaces with low emittance have high reflectance. Reflective insulations have emittance values in a range of 0.04 to 0.1. Characteristics of insulation. Insulations have different properties and limitations depending upon the service, location, and required longevity of the application. These are taken into account by engineers when considering the insulation needs of an industrial or commercial application. The insulating material used for steam pipes should possess the following properties. It should have high insulating efficiency. The maximum heat loss from insulated pipe should not exceed 1 kcal per hour per square meter per degree centigrade. Insulating efficiency is equal to their evident by their surface loss. It should have high mechanical strength so that vibrations and knocks will not adversely affect it. It should not be affected by moisture. It should not cause corrosion of pipes if chemically decomposed. The material should be easily applied or removed. It should be able to withstand the temperature to which it will be subjected. It should be stable and resist deterioration over the working life of the pipe. It should be easily molded and applied. It should not overload the pipe by its dead weight. It should not be too costly. The materials most commonly used for steam pipe insulations are asbestos, magnesium, cork, aerosol, roll felt, rock wool, and diatomaceous earth. Most commercial insulations are either built up from corrugated asbestos paper or laminated asbestos paper artificially roughened to produce air spaces or are molded or felted with asbestos. A very common and effective insulation for temperature up to 400 degrees centigrade is the molded 85% magnesia, which comprises 85% carbonate of magnesia and 15% binder. The insulation used for higher temperature should have interlayers of special high-temperature insulation as high temp. Decomposes the inner layers of magnesia. High temperature breaks down the magnesia into asbestos fiber and magnesium oxide and therefore destroys cohesion between the pipe and insulation. A layer of glass wool before hitting the layer of magnesia is generally used for pipe insulation when the temperature is above 400 degrees centigrade. Glass wool has an advantage of cleanliness, is non-inflammable, and can withstand vibrations and rough handling without losing its form or insulating efficiency. The packing density is varied between 100 to 150 kilograms per cubic meter as per requirements. The small steam pipes should have the same insulation thickness as large ones as the heat loss per square meter on a small pipe is higher than large pipe. The insulation manufacturers publish wave accent insulation efficiency wave accent data for different thickness of the different grades of insulation. Such tables generally provide the efficiency data against two variables as pipe size and temperature difference. The amount of insulation to be applied is an economic problem like many other power plant design problems. The cost of insulation must be weighed against the saving of heat energy obtained due to insulation. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.